supermassive black holes, lots of launches, NASA squashed an asteroid, and Slim has somehow woken up again? I'm Elysia Segal for NSF. It's Friday the 29th of March, and there's much more to come this week in Spaceflight. When NASA's DART mission was conceived, it was supposed to test that we humans can effectively change the orbit of an asteroid by slamming a spacecraft into it at high speeds. After all, that's what DART means, Double Asteroid Redirection Test. The test went successfully, and the asteroid's orbit was changed, but it wasn't the only thing that was changed as a result of that test. DART's impact target was Dimorphos, a small moon of a larger asteroid called Didymos. You might remember this from when we covered it live here at NSF a couple of years ago.
Yes, we did it! Do you have pom-poms, Elysia? You're like, cheer.
I do, because this is amazing!
The impact successfully changed its orbit, reducing it from 11 hours and 55 minutes down to 11 hours and 22 minutes. Now, a new study from a group led by Shantanu Naidu, an engineer at NASA's Jet Propulsion Laboratory, has shown that the object's shape has changed, and substantially too. The team used the images of Didymos and Dimorphos that were received from DART's camera before the impact, which were a good source of information as to what was the shape and the size of both objects at that time. Then, using radio signals from the Deep Space Network's Solar System Radar in Goldstone, the team was also able to precisely measure the positions and the velocities of the objects after the impact, and this helped them to precisely determine the new orbit of Dimorphos. Then, using several ground telescopes, the team also gathered the light curves of the two objects after the impact. This is essentially a plot of how the light we observe from them changes over time, and depending on their shape and their speed of rotation, the curve will look one way or the other. This light curve can be altered over time when one object passes in front of the other as they orbit each other, either because Dimorphos is in front of Didymos or because it is behind it. So this further helped the team to accurately measure the shape of Dimorphos after the impact. And what they found is that their observations match with a model in which Dimorphos went from looking more or less like a sphere to looking more like an amorphous blob of rocks just kind of clinging together by gravity. Now, the technical term for that is triaxial ellipsoid, but you probably understood the concept better with the other description. So this study is quite a big deal, as it uncovers a lot of interesting science. On the one hand, we get to know what would happen to an asteroid of this size and composition if we were to hit it for real and not just as a test. It also gives us more data on the consistency of asteroids. For example, are they more like rubble piles held together by gravity, or are they more solid? This study suggests that Dimorphos was indeed more of a rubble pile asteroid like Bennu and Yugu, which were visited by NASA's OSIRIS-REx and JAXA's Hayabusa 2 spacecraft, respectively. Now, hopefully we'll never have to use this technology, but it sure is interesting to learn lots of cool new stuff with test missions just like this one. Now let's take a look at this week in launches. Starting off the week, we had the launch of another crew going up to the International Space Station. Liftoff of the Soyuz MS-25 mission took place on March 23rd at 12:36 UTC from Site 31-6 at the Baikonur Cosmodrome in Kazakhstan. The launch had suffered a rare abort on its first launch attempt on March 21st due to low voltage from the first stage battery system. On its original launch date, Soyuz was tracking a 2-orbit 3-hour rendezvous with the station, but due to the abort, the spacecraft had to revert to a 34-orbit 2-day rendezvous on its second launch opportunity. Launching on board Soyuz MS-25 were Roscosmos cosmonaut and spacecraft commander Oleg Novitsky, Belarusian spaceflight participant Marina Vasilevskaya, and NASA astronaut Tracy Caldwell-Dyson. Novitsky and Dyson are veteran flyers, with this trip being the 4th and 3rd time flying into space for them respectively. This is Vasilevskaya's first trip into space, and the first time a Belarusian woman has traveled into space as well. The trio docked to the ISS Prashal module on March 25th at 15:02 UTC, and while the spacecraft will remain on station for 6 months, 2 of its 3 occupants will not. Vasilevskaya and Novitsky are visiting the station for a short stay and will be returning on the Soyuz MS-24 spacecraft no earlier than April 6th, along with NASA astronaut Laurel O'Hara. O'Hara's launching crewmates, Oleg Kononenko and Nikolai Chub, will remain on station along with Dyson and the Crew 8 crew for another 6 months. Kononenko, Chub, and Dyson will then return in September on the Soyuz MS-25 spacecraft. It's quite a juggle of people. By then, Kononenko and Chub will have stayed on the station for about a year during this mission, and Kononenko will have surpassed a total of 1,100 days in space. We also had a Falcon 9 launch from Launch Complex 39A in Florida on March 24th at 3:09 UTC. It was carrying another batch of Starlink V2 mini-satellites into low Earth orbit. The first stage for this mission, B-1060, was flying for a 19th time, which matches SpaceX's current record for most flights of a booster. It successfully returned to Earth, landing on SpaceX's drone ship Just Read the Instructions. Just a few days after that, we had another Falcon 9 launch taking place on March 25th at 23:42 UTC from Space Launch Complex 40 in Florida. The rocket was carrying 23 Starlink V2 mini-satellites into low Earth orbit. This marked the fastest turnaround time for a specific pad to be converted from Dragon configuration to a Falcon 9 fairing configuration, bringing it from 8 days to just 4 days. If you remember, the mission prior to this from Slick 40 was the CRS-30 mission, a Dragon mission. For these missions, the transporter erector is fitted with specific hardware at the top of the strongback that's exclusive to them. This Dragon-specific hardware then has to be removed, and in its place, teams install the specific hardware that we see for all of the missions that use a fairing. We often see this process at LC-39A, but this was the first time for Slick 40 since 2020, and the first time with Dragon 2 hardware at all. There's also a record worthy of mention on the recovery for this mission. The first stage, B-1078, was flying for an 8th time, and it successfully landed on SpaceX's drone ship, a Shortfall of Gravitas. Apart from this adding to the really long string of successful consecutive landings for Falcon boosters, the drone ship also returned back to the Cape in record time. A Shortfall of Gravitas arrived at Port Canaveral a mere 50 hours after B-1078 landed on its deck. Thanks to its powerful tug, Signet Warhorse 3, the duo was able to pull off the trip at an average speed of 7 knots and even as fast as 11 knots at some points, and that's fast when you're carrying a reusable rocket booster on top. Of course, record trip times like this are key for SpaceX to keep up with its launch cadence. The faster these vessels can be turned around, the faster SpaceX can launch. This drone ship went back out just this morning for its next mission, which hopefully will be taking place this weekend. Now let's go all the way to China. From there, we had the launch of a Chang Zheng 6A rocket on March 26th at 22:51 UTC from Launch Complex 9 at the Taiyuan Satellite Launch Center. The rocket was carrying the Yunhai 302 satellite to sun-synchronous orbit. Not much is known about this satellite, other than what's been officially reported, such as atmospheric and oceanic research, study of the space environment, disaster prevention, and other scientific experiments. But based on the study of previous Yunhai satellites, this one's probably going to be used for military research purposes, especially for weather monitoring and prediction. In more science news, this week we got a brand new view of the supermassive black hole at the center of our galaxy. Astronomers from the Event Horizon Telescope studied the black hole in polarized light, finding strong magnetic fields swirling around this massive object. The black hole is known as Sagittarius A star, or Sag A star to its astronomer friends. It's about 27,000 light-years away from Earth and has a mass of about 4 million times that of our Sun. Supermassive indeed. The first image from this black hole, released back in 2022, already resembled that of the black hole at the center of the Messier 87 galaxy, which was released back in 2019. The trick, however, is that M87's supermassive black hole is over 1,000 times more massive than Sag A star. M87's supermassive black hole is a powerful and massive black hole with lots of activity, and prior studies of its light showed that, indeed, powerful magnetic fields around it helped it shoot jets of plasma into its surroundings and even into intergalactic space. This resemblance between black holes prompted the teams to study Sagittarius A star to see if something similar could be going on. Now, it's important to note that this is not a direct image, but rather a visualization of the data captured at the same time by several different radio telescopes spread across the globe. The data from these telescopes has been pieced together and combined to essentially create an Earth-sized virtual telescope that we can study and get information from. And this is needed because, while the black hole is really big, it's also located very far away, and its size in the sky is just too small to resolve with a regular telescope. Astronomers from the team used a similar method in order to observe the polarization of the light coming from both M87's supermassive black hole and Sag A star. The result was that both our galaxy's supermassive black hole and M87's had very similar magnetic field structures, suggesting that these processes and structures may be similar across very different sizes of black holes. More observations are scheduled in the future to further study Sagittarius A* with even more telescopes involved, so hopefully we'll get a lot more data to understand how this process occurs. And whenever that happens, you can bet we'll talk about it. The French government has contracted 4 French launch companies to demonstrate that they can launch small satellites into low Earth orbit. France's President Emmanuel Macron announced the contracts earlier this week during a visit to the Guiana Space Center. The French space agency, CNES, will provide 4 payloads for 2 different mission profiles tailored to the different rockets. Latitude and Hyperspace, which is short for Hybrid Propulsion for Space, will both put a 50-kilogram satellite into a 400-kilometer orbit. The other companies, Sirius Space Services and Ariane Group subsidiary Maya Space, are tasked to put an 800-kilogram payload into a 600-kilometer sun-synchronous orbit. All of these companies are already in the process of developing and building small satellite launchers, so let's do a quick overview of them. Latitude is working on a rocket called Zephyr, powered by kerosene and liquid oxygen. It'll be 19 meters tall and capable of launching 200 kilograms to low Earth orbit. While the company aims to create a fully reusable rocket much later into the future, it's aiming to debut Zephyr much closer in time, in 2026. Meanwhile, Hyperspace is working on its Baguette 1 rocket. And no, that's not a joke, that's literally the name of the rocket. The rocket's not an orbital rocket, but it will be testing the hybrid propulsion technologies that the company aims to use on its OB-1 orbital rocket. This OB-1 rocket should be able to launch between 200 and 250 kilograms into low Earth orbit and will hopefully debut before 2027. Sirius Space Services is developing 3 rockets which will be powered by methane and liquid oxygen and could eventually be reusable as well. Sirius 1 would be the smallest of them, with 1 single first stage booster and capable of lifting 175 kilograms into sun-synchronous orbit. The company aims to debut this rocket in 2026, which will be followed later in the decade by the Sirius 13 and Sirius 15 rockets, each having 3 and 5 first stage boosters. These would have capacities of 700 and 1,100 kilograms to sun-synchronous orbit respectively. The fourth of these companies, Maya Space, is a subsidiary of Ariane Group and is developing a partially reusable methane-fueled rocket. The company aims to debut this rocket in 2025 and to begin first-stage recovery flights in 2026. The rocket would be capable of launching up to 500 kilograms in reusable configuration and 1,500 kilograms in expendable configuration. The contracts are estimated to total 400 million euros, but the 4 companies aren't handed all the money right away. They must first prove their capabilities by launching between 2026 and 2028. So, it's going to be quite the road for them. We wish all of the companies the best of luck. Now let's take a quick glimpse at some other stories across space. The Indian Space Research Organization, also known as ISRO, has completed a second flight test of its future reusable spaceplane. The mission, called RLV-LEX-02, did not go into space, but it did test the ability of the spaceplane to autonomously land on a runway from off-nominal initial conditions. The vehicle was dropped from a helicopter at an altitude of 4.5 kilometers, performing a successful landing on the runway at the Aeronautical Test Range in Chitradurga. This is the second landing test in a long series of tests of India's RLV development program, which first began by testing the hypersonic re-entry of this winged vehicle. This development program should hopefully culminate in an orbital test flight of this spaceplane in the next few years, adding India to the list of countries with their own reusable orbital spaceplane. Guess who's back? Back again. Slim is back. Tell a friend. Sorry, I had to. The little Japanese lunar lander has woken up again after another cold and frigid night on the moon. Now, there have been a few lunar lander stories lately, kind of wild to say that, so to refresh your memory, this is the one that landed on the wrong orientation. Wait, there were 2 that did that. Okay, so this is the one that was supposed to land sideways, but near the end of its landing, a nozzle fell off, and that caused it to instead land heads down. That's more clear, right? This little guy landed on the moon back on January 19th, and since then, it's already spent 2 nights on the moon, and it's still kicking. That being said though, teams have already started to see some systems like temperature sensors and unused battery cells starting to malfunction. After all, the spacecraft wasn't made to survive the lunar night. But as long as Slim is sending data back every lunar day, like this view from its navigation camera, the teams will keep on listening for its signals and downloading as much data as possible. Looks like Slim survived that shady lunar night. It seems like every week there's always some space drama, and this week it's Boeing and Virgin Galactic's turn. This week, aerospace giant Boeing filed a court case against space tourism company Virgin Galactic. The dispute was over unpaid bills, and it wants its trade secrets to remain secret. More on those in a bit. In 2022, Boeing subsidiary Aurora Flight Sciences was chosen to build 2 new motherships for Virgin Galactic. Right now, Virgin uses the VMS Eve mothership to air-launch the VSS Unity spacecraft. Virgin needs a replacement for Eve, and it's also busy working on its new Delta spacecraft to replace Unity and ramp up flight cadence, so, of course, more motherships are needed. Boeing and Aurora claim that Virgin has failed to pay around $25 million for work that they've carried out. Additionally, the companies are demanding that Virgin return the technical specifications and modeling equations that Aurora accidentally handed over to Virgin as part of their design work. The equations are Aurora's way of ensuring new aircraft designs work per the specifications. These trade secrets were not part of the deal, and Aurora wants them at the very least destroyed so that neither its competitors nor Virgin Galactic can use them. The relationship appears to be over, and the companies are heading to court. Aurora says the new design can't be built for the price and in the time specified, while Virgin is contesting the lawsuit, claiming it to be wrong in facts and law. I'm already prepping the popcorn, y'all. Now, let's break the ice by talking about de-icing. I know that's a really bad pun, but this week, the European Space Agency confirmed it successfully de-iced its brand new Euclid space telescope. The agency claimed that during the last few weeks, scientists started to notice that the light hitting Euclid's sensors was slowly getting dimmer. The conclusion was that the telescope was slowly building up a layer of ice just a few nanometers thick. But where did all that water come from? Well, it was absorbed from the atmosphere during assembly. This was not unexpected, so shortly after Euclid's launch last year, ESA pointed it slightly towards the sun for a few days to warm up the telescope and evaporate the water. But this wasn't enough to get rid of it all. This time, ESA couldn't use the same procedure because the large temperature differences would upset the precise alignment of the optical systems that were calibrated after the first de-icing. So, to remove the ice, engineers used onboard heaters to warm a mirror from -147 degrees Celsius to -113 degrees. Still very chilly, but it solved the problem, and scientists saw the amount of light collected increase by 15% almost immediately. ESA expects ice to slowly build up again, but it can repeat the same process every 6 to 12 months if needed. Scientists believe this will have little impact on Euclid's epic mission of studying dark matter and dark energy. It's been 5 weeks since the landing of Intuitive Machines' Odysseus lunar lander near the lunar South Pole, and the landing, while quite rough, didn't stop the spacecraft from sending signals back to Earth and attempting to perform as many science experiments as possible. It finally shut down on February 29th, 1 month ago, as the lunar night approached. Although we've seen SLIM surviving the lunar night twice now, it's not always guaranteed that this will happen for every lunar lander. In fact, there are more examples of landers not surviving than surviving. Sadly, this week, Intuitive Machines confirmed, as expected, that Odie was not calling back home after the lunar night and most likely didn't survive, meaning that its mission was officially completed on February 29th when it shut down forever. It's unclear which components or systems exactly may have failed overnight, and there's really no way to find out. It could have been anything. For example, the spacecraft may have had healthy power, but not communications, in which case it wouldn't be able to send signals to Earth, so it's impossible to tell. Despite Odie's problems during landing and then its expected eternal lunar slumber, Intuitive Machines is marching forward onto the next mission, IM-2, set for later this year, and this time they'll have a lot more data to make things go much more smoothly. NASA's Europa Clipper spacecraft has successfully passed pre-launch testing. The spacecraft was put through its paces over the last few weeks, having passed several tests of its electrical and thermal systems, as well as being subjected to shock and vibration testing. Europa Clipper will now undergo a series of post-testing checks ahead of being shipped to the Kennedy Space Center later this spring. During the summer, the spacecraft will be outfitted with all of the necessary components for flight and will be loaded with the propellant for its propulsion systems. The spacecraft will then be mated to Falcon Heavy's payload adapter and encapsulated ahead of launch. Everything remains on track for Europa Clipper's journey to Jupiter, slated to begin no earlier than October 10th of this year. And now, let's see what's coming up next week in spaceflight. Starting off the week, we'll have the launch of a Falcon 9 from Launch Complex 39A in Florida, carrying the Eutelsat 36D communications satellite. The 2.5-hour launch window is set to open on March 30th at 21:52 UTC. Just a few hours after that, we'll have another Falcon 9 launch from neighboring Slick 40, carrying another batch of Starlink satellites. The 1-hour launch window is set to open on March 31st at 1 o'clock UTC. And all the way from Kazakhstan, we'll have a Soyuz 2.1B launch to close out the month of March. The rocket will be launching the Resurs-P No. 4 spacecraft from Baikonur on March 31st at 9:36 UTC. The final launch of Delta IV Heavy has now been moved to after this episode. ULA is working on an issue with a liquid pump that supplies gaseous nitrogen that's used to provide pneumatic pressure to the launch vehicle systems. While the company still needs to solve this issue, the earliest launch opportunity could happen on Monday, April 1st, within a 4-hour window that opens at around 17:25 UTC. Stay tuned to our channel for any updates, as we'll obviously be covering that launch whenever it happens. Lastly, if you follow any of our social media, you may have heard that yesterday, the NSF YouTube channel just hit 1 million subscribers. That's amazing! On behalf of all of us here at NSF, thank you so much for your support over the years. Today, March 29th, is actually our 5-year anniversary on YouTube, but we couldn't have done it without all of you, your likes, your subscriptions, and all of your generosity. We can't wait to bring you even more amazing coverage and welcome another million into the incredible NSF community in the coming years. Thank you. And that's been your weekly update of spaceflight news. We'll see you all again next week to recap this week in spaceflight.